In section 8.2, you're going to learn all about the properties of a parallelogram. So a parallelogram is a quadrilateral with two pairs of parallel sides. So the opposite sides are going to be parallel. If we look at the figure, AB and CD are marked parallel. That's what the arrow on each of them means. So AB is parallel to CD. Also, since AD and BC each have two arrows on them, they are also parallel to each other. So AD is parallel to BC. Then, once you know that you have a parallelogram, once you know that the opposite sides are parallel, then you know different properties. So the first thing that we know is that the opposite sides are congruent. Sorry, the opposite angles are congruent. So if I look in the diagram, I'm given that angle A is congruent to angle C, and angle B is congruent to angle D. In a parallelogram, the angles are always congruent. Likewise, the opposite sides are also congruent. The opposite sides are also congruent. So if I look in the diagram, I can see that the opposite sides are marked congruent. The tick marks, when they have the same number of tick marks, that means that they are congruent to each other. Another property that's important for you to know is that the consecutive angles are supplementary. The consecutive angles are supplementary. And remember, supplementary means they add to 180. So if I look at my parallelogram, A and D are consecutive angles. They're next to each other, so they add to 180. Also, C and D would add to 180 because they are consecutive angles. B and C are also consecutive angles, so they also add to 180. And then A and B are consecutive angles, so those also add to 180. Now let's look at some examples that deal with properties of parallelograms. So we're given that PQRS is a parallelogram, so the opposite sides are parallel. PQ is parallel to SR, and SP is parallel to RQ. So we know that all the properties we just learned are true. Then we're given that PQ is 20, QR is 15, and angle S is 70. In part A, we're looking for the length of SR and the length of SP. Now, since SR is opposite PQ, we know that SR and PQ are congruent, so SR is 20. Then, we're also looking for the length of SP. Since SP is parallel to RQ, we know that they are congruent to each other also, so SP is 15. In part B, we're looking for the measure of angle Q. Angle Q is opposite angle S, and we know that in a parallelogram that opposite angles are congruent. So angle Q is 70. In part C, we're looking for the measure of angle P. Angle S and angle P are consecutive angles. So because they are consecutive angles, we know that they are supplementary. Angle S and angle P have to add up to 180. So angle P is going to be 180 minus 70. Angle P is 110 degrees. In the next example, again, we are given that we have a parallelogram. LMNO is a parallelogram. Because it's a parallelogram, we know that the opposite sides are not only parallel, but they are congruent to each other. So LM is congruent to ON, and MN is congruent to LO. So if I'm looking for the value of X and Y, to find X, I would do 6X minus 7 equals 2X plus 9. To solve then, I would subtract 2X from both sides. 4X minus 7 equals 9. Then add 7 to both sides. 4X equals 16. Then divide by 4, and I get X is 4. Then for Y, MN equals LO, so Y plus 3 equals 12. To solve for Y, I subtract 3 from both sides and get Y is 9. Anytime you have a parallelogram, you know the opposite sides are not only parallel, but they are congruent, so you can set their measures equal to each other. In the next example, we are given that ABCD is a parallelogram. AD is parallel to BC, and CD is parallel to AB. Because this is a parallelogram, we know that the opposite sides are congruent, and the opposite angles are also congruent. So that means that angle A is congruent to angle C, which means their measures are equal. So 2X plus 36 equals 3X minus 5. Then solve for X. So subtract 2X from both sides. 36 equals X minus 5. Then add 5 to both sides. X is 41. In the next example, again, we are given that ABDC is a parallelogram. So AB is parallel to DC, and AC is parallel to BD. Because we know this is a parallelogram, we know two properties about the angles. The opposite angles are congruent. So angle A is congruent to angle D, meaning X is 80. The other property that we know is that the consecutive angles are supplementary, meaning angle B and angle D add up to 180. So Y is 180 minus 80. Angle Y is 100. Then, since Y and W are opposite angles in a parallelogram, they are congruent. So angle W is also 100 degrees. The last property we have about parallelograms has to do with the diagonals. The diagonals of a parallelogram bisect each other. What that means is they cut each other in half. They split each other in half. So if I look at parallelogram ABCD, AE is congruent to CE because the diagonals bisect each other. They cut each other in half. And then also BE is congruent to DE. When I look at this example, it says in ABCD, if AC is 56, find AE. AC, the whole length, is 56. And I want to find AE. Remember, the diagonals bisect each other, so AE is going to be half of 56. AE is 56 divided by 2. AE is 28.